But at any rate, there's also something called a high pass filter. Now a high pass filter is just a filter that allows the high frequencies through. As you notice, it's like masking this, and if you're just paying attention there, you realize that the high pass is exactly the same as a low shelf. Really, there's no difference. It's just the way you think about the terminology. So you have a low shelf and a high pass are the same. And conversely, the high shelf and the low pass are also the same thing. Okay, it's just the terminology used, and Reaper is just kindly giving us both types here. Okay, but they're the same. And there's a couple other bands in here you can experiment with, but mainly we'll be dealing with bands and shelves, or if you want to call them high pass and low pass filters, that's fine too. Okay, so that's our EQ. Okay, let's do a quick review. We have the frequency sweep, gain, and bandwidth types, selectors, and then we have the indicators here that tell us exactly where it is, not just a mysterious slider. Okay, and you can add or remove as many bands as you like, but I strongly recommend not having more than 4, 5 if you absolutely need it. But you'll find that most of the time you're just dealing with like 1 or 2 adjustments in a particular track, and we can select our band types here. Okay, here's a 5-band EQ plugin, but I've got everything completely masked because I'm using a high pass filter. Okay, it's only allowing high frequencies through. Here's one with the low pass filter. All right, remember, high pass and low shelf are the same. Low pass and high shelf are the same. This is all completely masked. All right, there's a bunch of random selections here. There's the high pass, a notch filter, just a standard band and the standard band. But the notch filter, kind of, you could use a band for it, but the notch filter is kind of locked in. You can't raise the volume on it. You can't raise the gain. It's fixed to remove specific frequencies. There's a convenience. Okay, there's a band pass filter, as we saw earlier, which is filters out everything except for the band that you select. And here's a little handy-dandy chart for you. This is not scientific, but it's kind of a semi-formal guideline as to how mix engineers categorize frequency ranges. So we use adjectives all the time, and I'm guilty of this too in class. I'm like, oh, this is muddy or crispy or crunchy or puffy or whatever. And, and if you if you haven't been mixing for a while, you may wonder, like, what is he talking about? So I'm hopefully clarifying some of it here. So very low bass. Frequencies are felt. They're visceral. They're felt rather than heard. Sometimes you hear the terms punchy, thumpy, right? We have a regular bass frequencies, which are more of tones that you hear at about the 60 to 250 hertz range. And these you may also hear like punchy or boomy sounds. The mid range is about 250 to 2000 hertz, and you don't want to usually boost this too much, because this is actually from the Reaper documentation. It says it sounds like you've recorded it from the other end of a telephone if you've put too much gain in. That's true, but it's also a term that we use called mud. And if something sounds muddy, it's probably the low mid range or mid range. It's usually in the area of about 250 to maybe, and I'm just guessing here, maybe like 750 hertz or something. That tends to be the mud range, and almost always, any sound can benefit from a little slight dip in that range, like a decibel or something, or 2 decibels. The upper mid range, as it says here, a tricky area, and that's true because we've already got those frequencies enhanced in our ears due to the equal loudness contour. Our ears are designed over time to really hone in on those speech frequencies, and we do need to boost them though in game audio a lot, because we're usually competing with a lot of stuff in a soundscape, especially like if it's an action game with a lot of dialogue. It's pretty tough. That's why we use ducking techniques and things like that. But anyway, if you have it too hot or too high up in volume all the time, it's going to cause listening fatigue if you have to listen to hours of this stuff. So sometimes we want to use what's called a ducking technique and bring everything else down imperceptibly, just a decibel or so, and then that audio the dialogue will come through without having to necessarily boost it. Okay, 4 to 6K is usually what's called the presence range. Okay, this is really for clarity of instruments and dialogue or vocals. Okay, and it has a nice kind of bright feel. I would call it a bright feel to it. And the 6 to 16K range is the high frequency range. That's a really general swath there for high range, but I would say anything in the 12K to 16K range, you can't really hear so much as you can sense. It's almost like this strange glassy perception. It's not really a tone anymore. But if you want to really make something feel like shiny, glassy, sparkly, crispy, I guess I don't know, you can get up into this high range and do some boosting, but you don't want to boost too much because well, you may upset your dog if you have a dog in the house for these ultra high frequencies, but it doesn't necessarily benefit much unless it's there's a lot of spectral content in the sound. Like if there's a lot of different frequencies in it, especially in the high range, you want to be careful with boosting it too much, but it will give you a nice glassy, crystally effect. Okay, let's move on to reverb and other effects. This is all like in the other category. You could also think of it as reverb and modulation, which is a term that we're just modulating or changing waveforms in various ways. So reverb, from the formal term reverberation, it adds a sense of room tone, I call it, room ambience, or natural acoustics to your signal. So maybe you're sitting in an empty building at WPI or something, and someone's talking to you, and you're talking to them, and you're maintaining your distance, or 6 foot distance, but there's an echo in the room because there's not a lot of people, there's not a lot of furniture, and this is room for reflections, and that's reverb. Okay, that's anything that you hear a reflection of your voice or a sound resonating, bouncing off a wall. And the more empty a space is, as we learned in lecture 3, the more reflections you'll have. Okay, and sometimes you have other things going on, like scattering of waves, diffraction, and that's still a type of reverb. And this will pile up. Like if you're in a gymnasium, you remember, high school gymnasium, and you're sitting in the bleachers, and people are talking, and you can barely understand them because everything's like, and you get kind of used to it. That strange, like, muddy reverb going on. It's this huge reverb tail, meaning like there's just cascade after cascade of reverb, reflections, and they're all like bouncing off of every surface because there's not a lot of insulation or not a lot of absorption of those waves. Okay. Anyway, with a reverb plugin, we can adjust that room size. We can increase the amount of reflections. We can even add, like, in a sense, we could add acoustic material to absorb or dampen. What we call a dampening effect to the reverb, and any other type of parameters you can imagine. There's the Reaper stock reverb, the free one, only has a few parameters we can control, but there are a lot of good plugins out there that have multiple, I may have 24 controls or something, and you can get very, very tweaky with it. But we're just going to use a basic one just for the sake of example here today. Okay, this is going to be the Reverbate, the REA Verbate plugin, and I've got only really 6, 7, 8 items here that I can show you. We really only need to know at the end of the day, really, like, one, not initial delay, but room size is the first one I want to start with. And this is where we can increase or decrease the amount of reflections. And it also means essentially we're increasing the room size. So the reflections are getting bigger, the wavelengths are getting traveling further before they come back at you, and you get this cavernous effect if you get this number too high. Now, they don't tell you if this is 48 feet, 48 meters, 48 Reaper units, 48 qubits. I don't know what it is. I don't. If somebody knows or finds out, let me know. But I'm gonna guess it's meters or something like that. And anyway, the room size, and then we're increasing it. You can go up to 99 I think, or 100, probably 99, and it's just too boomy and too echoey at that point. But that's when you can start to apply some other controls. The initial delay is how far the signal travels before hitting that first wall, like the very first reflection. And so if you increase this, you can get kind of this slap back effect a little bit. I usually don't mess with it unless I'm going for some super special effect, like when a machine, science fiction machine sound or creature sound or something like that. So room size is really the most important one. There's something called dampening, and this is like how much feedback is there going to be? In other words, is anything stopping these reflections from ping-ponging around like a bad version of Pong on steroids? And it's almost like acoustic material, if you will, that's dampening those reflections and slowing them down. So you don't have this huge tail or reverb tail, we call it, just kind of mud. There's also a stereo width control, which we're not going to mess with. We want it in stereo. So 1.00 means yes, you are in stereo. If you lower that, the image becomes more narrow and feels like it's more in the center of your head than it is on either ear. And then there's a low pass and high pass. Now, a lot of plugins, Reaper or otherwise, have low pass and high pass plugins, kind of what we call side chains. There's these little extra added bonuses like, oh, while we're here, we'll just add this low and high pass for you. And what this does is it says that maybe I don't want to have reverb all over the place, right? Just like the compressor had that earlier. And so I can select a window of frequencies just by bringing the high pass up and the low pass down, or I can slide them around. And there may be some reasons why you want to do this with reverb, like if there are certain things like a cave, a tank, a gymnasium, a cathedral. They all have different reverb types, and we can kind of experiment with these and see if we can make the reverb sound brighter, darker, kind of mid-rangey, or just kind of leave it alone and do full spectrum.